Hello everyone, I am Tahira Mazumder from IT department, Akgec Engineering College. Today I'll be talking on the topic of transposition cipher, which comes under the subject of DEC, that is data encryption and compression, and with subject code HTS 501 under the University Akgec. To start with, let us first talk about the topics on which I'll be talking about. I'll first give a brief introduction to transposition cipher, what exactly transposition cipher is. Then I'll differentiate transposition cipher from the other kind of cipher, which we call it as substitution cipher. Then we'll be talking about the types of transposition cipher that we have, that which are basically this. We have this rail fence, columnar, transposition cipher, simple, double, and so on. All of these ciphers basically comes under two categories of cipher. One is keyless cipher, and the other one is keyed cipher. So we'll be talking about this subsequently in the other slides. To start with, what is transposition cipher? Transposition cipher is basically a cipher. What is cipher? Cipher is Cipher is an encryption algorithm, encryption as well as decryption algorithms. So we ciphers are also called as encryption and decryption algorithms. So we have various kinds of ciphers. Broad categories are two types: transposition and substitution. At transposition cipher, what it does, it whatever letters that we are trying to work upon, that is, we are trying to convert from plain text to ciphertext. As we are doing the conversion from plain text to ciphertext, transposition cipher does not do any substitution on the letters of the plain text. What it does is that it just changes the location of the symbols that are there in the plain text. So we can say like that the transposition cipher basically transforms a message by rearranging the position of the elements of the message. That means, whatever, for example, we have a message, or we also call that as plain text. Like, for example, we are having, this is our message. Then the cipher or the ciphertext, if we are using transposition cipher algorithm, these letters will not be substituted by some other letters. We'll just rearrange the position of the letters in that particular message, or position of the symbols in that message. Like, for example, we can say the new set of letters, like it will be L, then we have L coming here, then we have E, O, H. If you compare these two, the letters are still remaining. Only thing is we have rearranged the position of the letters in the plain text. So that is what transposition cipher does. It rearranges the position. Now, if we just make a brief comparison between the two important kinds of cipher, one is the transposition cipher and the other one is substitution cipher. If we make a comparison, we can say the substitution cipher, basically it is one in which the letters of the plain text are replaced by some other letters or symbols or numbers. In contrast to that, in the case of transposition cipher, we don't replace the letters or the symbols that are appearing in the plain text. What we do is that we rearrange or rather we change the positions of the letters or the symbols that appears in the plain text. So comparatively, the substitution cipher is easier to understand when you compare that with the transposition cipher. Some examples of substitution cipher are Caesar cipher, monoalphabetic cipher, homophonic substitution cipher, Vigenère cipher, one-time pad cipher, and so on. These are examples of substitution cipher. When you're talking about examples of transposition cipher, we have examples like rail fence cipher, columnar transposition cipher, which again has two types: the simple, the double columnar transposition cipher, and so on. We'll be learning about this later on in the coming slides. So let us start with the types of transposition cipher. So we have this, basically when you're talking about the types of transposition cipher, we have this two broad categories of transposition cipher. One is the keyless cipher and the other one is the keyed cipher. And we can also combine these two and have another kind of cipher where we are getting a new kind of cipher by combining the keyless and the keyed cipher. To start with, let us start with the first one, that is the keyless transposition cipher. Now we take an example as the name suggests, when you're talking about keyless cipher, what happens? No keys are used. No keys are used in these kinds of algorithm, which are keyless ciphers. And when you're talking about keyed cipher, in that case the key is used or the key is required. So let us start with keyless transposition cipher. In case of keyless, as I told you, no keys are required for this particular kind of cipher. So one very the first example that comes to mind, and one of the simplest cipher which comes under the category of keyless cipher, is the rail fence cipher. So in this case, this is one of the simplest transposition cipher. Here each letter is written in a zigzag pattern. It is written in a zigzag pattern. It is something like, why is it called rail fence? Because if you visualize the railway tracks, so this is how a railway track looks like, fine. So what we do is that we position our letters which we want to encrypt in zigzag manners. Like here will be the first letter comes in the first row, second letter comes in the second row. It will be something like this. The letters will be placed in the zigzag manner. This is how the look comes. So if you take an example, let us take an example of a plain text. The plain text is meet me at the park. Now meet me at the park, you want to convert it to a ciphertext using transposition cipher, which is keyless cipher. So what we do is that we are basically, as I told you, we are assuming that we are taking the railway line, for example, and this is how the railway line goes. This is how the railway line, the tracks inside the railway line is, fine. And as we consider this kind of scenario, then what we do, we place our letters in a zigzag manner. First letter meet, E goes in the next row, the other G comes in the first row, then T comes in the second row, me. So this is how we are placing the letters in the zigzag manner. This is how the letters are placed in a zigzag manner when you're preparing for doing the encryption of the plain text. Our plain text is meet me at the park. So once the letters are placed in a zigzag manner, assuming with the look of the track of how a railway line looks, once they are placed in a zigzag manner, next what we do is that we read the text row wise. As we are doing the encryption, read the first row, whatever letters come in the first row. The first letter is M, the next letter is E, M, A, T, E, A, K. So once all the letters of the first row are read, then we'll move on to the letters of the second row. So the letters of the second row is again, next we have E, give me a moment. So this much is for the first row. Then start with the second row. So when you're starting with the second row, it will be E, T, E, T, E, T, E, T, H, P, R, H, P, R. And this is how the ciphertext is prepared from the plain text using the simplest cipher that we call it as the rail fence cipher, which is keyless cipher. So in case of columnar transposition cipher, the message that we want to encrypt is written out in rows of fixed length, and then it is read out again column wise, and the columns are chosen in some scrambled order. So if it is that decides if you are going for keyed columnar transposition cipher or keyless. If it is keyless, then we'll be choosing the column in increasing order, the first column, the second column, the third column. Or else if it is keyed, then the keys will decide in what order the columns are chosen. The width of the rows and the permutation of the columns are normally defined by a keyword. That is a normal practice when it comes to going for columnar transposition cipher. We normally go for keyed cipher, but we can also have a keyless cipher. In this example, this is an example of a keyless transposition cipher where the plain text that we want to encrypt, the plain text that we want to work upon is meet me at the park. This is the plain text that we want to encrypt, and in this columnar transposition cipher, what is required is the fixed rows of fixed size. In this case, we are assuming that the size of the row, or rather we can say the number of columns or the size of the row is 4. That means in each row you need to meet me at the park. So once the letters are placed, then we will be reading the letters from this matrix column wise. That means if you see, we are writing in this matrix row wise, that is during encryption, and when you are reading, when you are retrieving, we will be going for column wise. And once you have retrieved or read column wise, then the whatever you have read, that will be a corresponding ciphertext. So in this case, now the last letter or in the last row and the last column is empty. So if required, you can leave it empty, or you can put a null value out here. It's our choice, because that will decide the core kind of programming that we do. We can choose to go for null values, or we can leave it as it is. Now in this case, we are assuming we are leaving it as it is. So we have written the plain text column or row wise, and then we are reading it column wise, and once we read it column wise, whatever letters we get, that will be our ciphertext. So the first set of letters is double MTA, then we have double EHR, then we have EAEK, followed by double TP. Now one more point is that it's a normal practice that whenever we are dealing with ciphertext and plain text, the letters in the plain text are normally in smaller case. And when this is a normal practice that we go, and the letters in the ciphertext, they are normally in uppercase. So if you look at this, we can see this. If you are analyzing the previous example, this is the example that we have taken, and we are saying that it is an example of a transposition cipher. Why so? Because if you see, whatever letters we have, all the letters are existing. We are not substituting a letter by another set of letter, but rather what we are doing, we are just rearranging the position of the letters. So give me a moment. So here, if you see, if you analyze this, like this is our plain text, meet me at the park. This is a plain text. So if you see how things change, the first letter remains as it is. Then what happens? The first letter is where it is. Then the fifth letter comes to the second position. That is first, second, third, fourth, fifth. The fifth letter comes to the second position. Then the ninth letter comes to the 1, 2, 3, 4, 5, 6, 7, 8, 9. The ninth letter comes to the third position. The 13th letter, that means A here is the 13th letter. The 13th letter comes to the fourth position, and so on. So this is how the letters are rearranged based on the position, and we have the same set of symbols as it is. Only thing is the entire positioning is rearranged. So this is the example which we have taken for columnar cipher, transposition cipher without keys, and this is how the positioning are changed. This is an example that we have taken. We have taken the position index to show how the positions are changed. Now let us come to the instance of keyed transposition cipher. When you're talking about keyed transposition cipher, the very name says that we are using key in those kind of ciphers. So as I told you, in case of keyed cipher, we go for keys. So in this case, what we do is that we divide the plain text into groups of predetermined size called blocks, and then we use the key to permute the characters in each block. Now if we have this, let us take an example. Let us say we have this enemy attacks tonight. This is a plain text. And let us assume that the key that is used for encryption and decryption is somewhat like this. This is used for encryption, and this is used for decryption. How these keys are generated, I'll take an example in the next slide and show it to you. So in this case, what does it mean? The first key is 3. That means the third letter becomes the first letter of the plain text, of the ciphertext. Next, the first letter of the plain text becomes the second letter of the ciphertext. The fourth letter, 1, 2, 3, 4. The fourth letter becomes the third letter of the ciphertext. Then we have the fifth letter, the fifth 1, 2, 3, 4, 5. The fifth letter coming to the fourth position. The fifth is coming to the fourth position, and then we have the second coming to the fifth position. So this is we are taking a block of size 5, and each block we are rearranging the position. The same thing we will do at the remaining 5 blocks and continue subsequently. I'll take one more example to explain this. Before that, let us just take the example of the cipher that we had taken previously, that was of railfan cipher. By default, we are just taking a zigzag line for the case of two lines, comparing it to that of a railway track. We can also have a situation where we can specify the key number for real fence cipher. Here we can say that, for example, if the key for a real fence cipher is 3, so in that case we'll be having 3 lines. You have, this is your first line, this is your second line, this is a third line. And once the 3 lines are placed, then we'll be placing the letters of the plain text in a jigsaw manner across the 3 lines. So let us say the plain text is, in this case, the plain text is defend the east walls. This is our plain text. Excuse me. Defend the east wall. This is a plain text. So we will be putting the letters in a jigsaw: D, E, F, E, and D, T, H, E, the, E, A, S, T, east wall, W, A, wall. And this, in this example, since we will be placing, so we have the option of whether to leave the remaining blocks as it is or whether to fill it up by null characters. This is an example where we are filling it up by 2 null characters, which we are taking it as X, and these are called nulls or placeholders. And this, why do you go for this? It is only to do so that the entire thing fits in the grid in a more easy way, and this will lead to more the process of encryption and decryption, if you're going for null character insertion, makes the coding or the algorithm much more easier. So once the letters are placed in a jigsaw manner, here the key is 3, so we are using 3 lines, and then what we do, we'll be reading it line wise. So D and E T is L, so D and E T L. Then you have double E D H E S W L X, so you have double E D H E S W L X. This is your second line, and this is a third line. So this is an example of a reinforced cipher where the key size is 3. Now what, let us just take one point. When you're talking about the case, if the encryption key is given, then what will be the decryption key? This is something which we can also calculate and find out. If, let us say, the encryption key is 31452, what does it mean? It means in the first position of the plain text, the third character comes. In the in the first position of the cipher text, the third character of the plain text comes. Then in the second position, the first character of the plain text comes. In the third position, the fourth character of the plain text comes. In the fifth position of the cipher text, in the fourth position of the cipher text, the fifth position of the plain text comes. So it will be something like this. Let me take an example, then it will be clearer. Let us say we have this as, let us say this is our plain text. So in this algorithm, so here L, then we have the first, so it will be H, 4, so it will be again L, 5, so it will be X, then 2, so it will be E. So this is how the encryption is done using this key. This is an example of, again, a transposition cipher where repositioning the letters of the plain text by using the key. Now if this is the encryption key, the decryption key will be something different. So it will be, let us say, if we are saying the third position come to the first one goes to second, the fourth one comes to third, the fifth one comes to fourth, and the second one comes to fifth position, as you're going encrypting from the plain text to the cipher text. And if you're decrypting, then you just have to rephrase. The second one comes to first, that means the second one comes to first, then the fifth comes to second, then in third the first one comes. Next, what happens? The third letter comes, and the last position the fourth letter comes. Now from this encryption key, how do you get the decryption key? We can very well see it diagrammatically and decipher it, but when it comes to coding, how do you do that actually? Now if you take the example, this is how we do it. Let us say this is an encryption key for how many letters we have? For 7 letters. So what we do is that the syntax is that we take the encryption key, give an indexing to the encryption key. So this is the first key, 1, 2, 3, 4. So we have indexed those letters of the encryption key. Once we have indexed, you swap both the thing. That means the letters, the indexing number goes on top and the key comes below. So if you look at this, so we have this set swapped, so we are getting this set. So whatever was the index, it has gone up, and the upper value for the key has come down. And once this is done, then the next point is sorted. Sorted in the sense, the first position that will be coming across. Just give me a moment. Let me erase the whole thing. In sorting, what we do is that we sort on the basis of index. So the first thing is 1. This 1 will come. What is the pair for 1? The pair for 1 is 4. So next is 2. For the pair for 2 is 1. For 2, 1 is paired. For 3, 3 is paired. For 4, 5 is paired. For 5, 7 is paired with 5. For 6, 2 is paired. And for 7, 6 is paired. So once we have done the sorting part, once the sorting is done, then we have retrieved, or rather we have found out the key, and the key decryption key is 4135726, and this is the algorithm for doing so. If you take up this example, it is something like this. So we start with 31452. We give the indexing to this. Let me use a different color so that this will be more understandable. So the indexing is 1 2 3 4 5. This is the first position. We are adding the indexing. The next part is we actually will be doing the swapping. So when you're talking about the swapping, what is there in the beneath row will be going on top. So 1 3 4 5 comes on top, and what will come on above, 3 1 4 5 2 will come above. After that we will be doing the sorting. Now when you're doing the sorting, we will be sorting on the basis of the lower index. So 1 2 3 4 5. So, and correspondingly we'll also add the corresponding pair. So with 1 it is 2, with 2 the pair is 5, with 3 it is 1, with 4 it is 3, with 5 it is 4. So the decryption key is 25134, 25134, and the encryption key is 31452. So this is how, if the encryption key is given. Now we can also have an approach where we can combine both we can have the third approach where we can combine both the approaches. Here the encryption or decryption can be done in 3 steps. In the first step, the text is written in a table row wise. In the second, the permutation is done by reordering the columns, and in third, the new table is read column by column. Here we are saying that we are going for a combined approach. How is it so? Here the first and the third steps, they provide a keyless global reordering, and the second step provides a blockwise keyed reordering. So we have keyed as well as keyless reordering. In the first and the third, it is keyless, and the second will be keyed. So let us take an example to understand how exactly it is taken care of. So let us take an example of the plain text, defend is wall of the castle. This is the plain text, and now we're talking about columnar transposition cipher with keys, and the key, let us say it is German. So to encrypt this message, we do the following thing. The first thing is we find out how many letters are there in the key German. We have 6 letters, 1 2 3 4. So our row size will be 6. Our row size in the matrix, the number of columns or the size of the row will be 6 based on the number of letters that we have in the key. So the row length is used as the same as the length of the keyword. Here it is 6, and then we write out the plain text in a row wise manner. The plain text is defend the east walls of the castle. So defend the east wall of the castle, and whatever remaining position we fill it up with some null characters. Once this is done, then we will be going for applying the key. And how do we apply? This is the matrix that we have created. Then we will be sorting the columns of the matrix on chronological order. That means if you look at it, the first letter, chronologically it is A that will come first, then it will be E, then it will be G, then we have M, then we have N, and then we have R. So once the columns are sorted chronologically, on the basis of the key, then as the columns are sorted, the corresponding letters corresponding to A key will also be placed in the first column, and after the column with key A, then the column with key E, if you are taking the corresponding letters of E in that column will also be placed in the subsequent position, and subsequently for that applies for all other symbols in the key, and then we are getting a new matrix. So this is the place where we are going for keyed approach. And once we are going for keyed approach, next, so if you're looking at it, first, this is the first step. The first step is we are arranging it row wise. The second step is we are applying the key. How we are applying the key? Whatever is the key, we are chronologically sorting the columns on the basis of the key, and then after we have reordered the key, the ciphertext is then read out along the columns. And in this case, we are not going for keyed approach, we are using a keyless approach. If you look at it, we can say this second step and the fourth step, this is keyless, and the third step is keyed. So now once this process is completed, so we take up the when you're talking about reading, we take up the first column. The first column is NALCX. This is the first column. Then we go for the second column, EHWTT, EHWTT, and so on. So this is an example where we are combining both the that is the keyed approach as well as the keyless approach. So we have, just to summarize, we can say in case of transposition cipher, we have these two approaches, the keyed approach and the keyless approach, and we can have a third one where you can combine the keyed as well as the keyless approach. So this is an example where combining the keys as well as the keyless approach.